Hello, hi everyone. Welcome to reInvent. I'm really excited today to talk to you about open source observability on AWS. My name is Rodrigue. I'm a specialist solutions architect, and I focus on observability. And today with me, I have Mark, who leads our product and engineering team at AWS, and Cody, who's the tech lead for observability at Stripe. So today, in this session, we'll talk about the challenges for open source observability, and then I will walk you through a demo. Cody is going to talk about their experiences at Stripe, and Mark's going to end with a presentation with what is new on managed open source at AWS. So to introduce this session, I wanted to walk you through a story, an example. So I want to talk to you about Jessica. Jessica is an SRE at Example Corp. Jessica is on call. It's Friday, it's the weekend, she's happy to go home, but she's on call. And at 11 p.m., Jessica gets paged. So classic stuff. So there is a canary testing that shows, that constantly tests the front-end application, and then she gets an alarm from that there are slow responses a little bit everywhere. So everything is fine. So Jessica, what she does, she says, okay, I have the perfect dashboard. I'm going to log in and find the issue and go back to my Friday evening. So she tries to log in into Grafana. She's managing Grafana on EKS in Example Corp, and Grafana is not reachable. Prometheus is not reachable, so she tries to access the dashboard using Prometheus, self-managed, and Prometheus is not available. All right, everything is good, everything is perfect. We have Prometheus browser expression. She's going to use that. Again, Prometheus browser expression is not also loading up, so things get a little bit intense, but no issue so far. The alerts start to escalate to Bob, so second engineer on call, the backup. So Bob joins the call and say, okay, Jessica, you try to see what is happening with Prometheus. I'm going to search through the application logs. Well, the problem is, it's a large microservices application. There's a lot of services. So where do we start? There's no pointer to see what application logs we should search for. So Bob says, okay, I'm going to search for it. I'm going to get it. Right, and Jessica is looking at the Prometheus stuff. All right, and a few minutes later, Sarah is the CTO. She joins the call because customers are getting impatient, and also support has a lot of calls. So Sarah joins the call, tries to see what is happening and see how she can make the situation resolve faster. So the engineers are working. So Jessica comes back with an answer and says, I think Prometheus ran out of memory. I saw a bunch of home kills in some logs, and probably out of disk space as well. All right. And Bob, a few minutes later, Bob also has some findings in the logs that there is a card service that has some problems to connect to the database. So there's a connection pool error in card service and probably other services as well. So we have identified some leads, and they're going to do necessary actions, like restart the services and try to recover the situation. So let's recap the event, what happened at Example Corp. So at 11 p.m., there is an incident that started. And from 11 p.m. actually, to 11:50, they were completely flying blind, trying to look at logs, don't know where is the root cause of the issue, and then going with experience, I think experience-based observability, where because they've been there for a long time, they kind of know the services, kind of know what they should look at. And yeah, and then after that, incidents is resolved, everything is going to recovery. So there is a famous quote that says that open source is only free if your time is not valuable. And there are some challenges in running open source for yourself. because you have additional overhead. You need to make sure that Prometheus, for example, in this example, will scale well, has a lot of space to host, to get all your metrics and query them. And also, in the open source community, there is a rapid cycle of releases. Everything changes all the time. If you open a web application that you build today, if you open it in 6 months, you try to compile it, nothing works, all the dependencies are broken, you know the story. And also, when you do go through all of this, you have limited support, limited people you can talk to get the issue resolved. Additionally, we didn't saw that in this example, but if any of you has gone through a compliance or security program, there's a lot of effort you need to do to maintain this level of compliance. And then having something that constantly change, not on your behalf, can make it more difficult to maintain. And so let's see with managed observability. So if you remove that part out of the equation, what this can look like. So this is an example, not necessarily how this will happen, but let's say 11 p.m. incident is open, and then you take a little bit of time to find the root cause. You focus on your application, and then we will point you to what are the signals that you should look at, and then you close the incident. So smaller time, reduce the mean time to recovery by focusing on what you need to build, your application. And how you do that on AWS for managed observability open source, we have Amazon Managed Service for Prometheus, which is a serverless Prometheus compatible, fully managed, that you can use to monitor any environment at scale. So we will scale on your behalf and we will match your needs. And on the other side, we have OpenSearch to host your logs and traces. We can even host metrics, but Prometheus is best suited for that work. Using OpenTelemetry, you can collect the data and then send to both locations. And when you have that, to visualize all of it, you have choice. You can use Managed Grafana to query metrics, and OpenSearch. You can use OpenSearch dashboards to also query your data sources. So a reference architecture that we see is data will come from many places, including AWS services like Lambda, ECS. So where your applications are hosted, you can collect the data from there. And we have also integration with many AWS services. For example, EBS has recently released support for EBS volume metrics ingested into Managed Service for Prometheus. And you typically use a collector with OpenTelemetry, or even Prometheus can also send the data across. We have managed collectors we released last year. So you can have, for example, for EKS, you can have your metrics collected by us, and you don't have to manage anything at all. You will have the destinations, Prometheus or OpenSearch, and then to visualize all of it, Grafana and OpenSearch dashboards. All right, so under the hood, how everything works for metrics collection. So you would, as I said, you would typically have an OpenTelemetry agent. On Prometheus side, we will expect you to send data with the remote write protocol with Prometheus. So it can be OpenTelemetry, or it can be any other collector that can do remote write. Inside Managed Prometheus, we have an ingester module. So we are based on top of Cortex. So this is the Cortex architecture. We have an ingester module that sends all your data into S3. This is completely managed by us. We will handle all the scaling, the patching, and all the operation that goes with it. So we will take it out of your hands and let you sleep at night. And when you use, as I said, when you use EKS, you can have all the collection also abstracted away from you. So you have the data in, how do you query it? We have a query API that you can use usually with Grafana, or HTTP API you can use as well. We support Prometheus API, so you can use API or Grafana. And that will go through the query module that also leverage S3. And you will need, if you want to do alerting, we have a ruler module and an alert manager module to process your rules and your alerts, so everything is managed inside the service. We connect through SNS, and everything is secured with VPC endpoint. So you can have security and then scalability completely managed by us. Right, so how do you do for logs ingestion? Usually with logs, you have FluentBit. You can connect a FluentBit agent in your workloads on EKS or whatever you run your applications. You can also have data in OpenTelemetry format. So if you have OTLP SDKs in your application, you can do that with your logs and use Amazon S3. Like you might have some logs on S3. You can connect all of it to an open source ingestion pipeline. So this is a fully managed data prepper service that you can run to collect data from your application, from your sources. Inside we have a buffer and a bunch of processors you can have to manipulate the data and send all of this to an OpenSearch domain or an OpenSearch collection. This is the fully managed serverless OpenSearch. And then Grafana and OpenSearch dashboard to visualize. So this is a little bit inside what is happening under the hood. All right. Something we have seen, because we usually recommend customers to run their application across multiple accounts, or sometimes you have requirements to run your application across multiple regions, and sometimes even on your own data centers, on different cloud providers as well. We can meet you there. You can run all of it, all this collection architecture, and centralize your observability into AWS. All right, I will walk you through now a short demo that connects everything I have said. All right, so for the demo, so this is the OpenTelemetry demo, if you're familiar with it. So it's a set of microservices that has a load generator, and then take traffic from the front end and distribute across multiple services. So this is deployed on my account, and then I'm running OpenTelemetry to collect all the data and using the reference architecture I just showed you. So I can see here, so this is the first dashboard that shows all the requests for all the services. So you can see add service, cut service, all the services, and the trend requests and the number of errors. And all of it comes from managed Prometheus. So if I show you the query behind it, so this is a Prometheus data source, and I do all these queries through Prometheus. So if I want to know more about a service and how the service is behaving, I can click here. I'm using Amazon Managed Grafana to visualize it. So I have a dashboard with all the logs volume. So I know also the traffic pattern on my application. The logs is also an OpenSearch query. So I'm using OpenSearch, an OpenSearch data source in my dashboard with Prometheus as well. And so I have information like memory, CPU, so all the classic stuff. And information about the trace spans, so I can filter some traces and then find what is happening in my application. So let's take, for example, a slow request. So I can filter by latency and select this trace. So I have a service map that shows me what is happening. So the traffic comes from the load generator, front-end proxy, and then goes to add service. Right. And you can see also the logs associated to that particular trace. So the logs are on OpenSearch, and the metrics are on Prometheus. And something interesting about this dashboard, I will show you really quick. So it's how the dashboard has been set. So the services are discovered in Prometheus. So I have a label in Prometheus that shows the services. And I use the service name to find all the traces in OpenSearch. So I can do a correlation between my metrics and my traces that are in different places. And I can go even deeper and then find a purposefully built dashboard for logs and traces. So here, for example, I can find the logs per namespace. So this is hosted in a Kubernetes cluster. I can find all the errors per container. So I have, as Jessica said, I have the perfect dashboard. This is the perfect dashboard. The difference is we manage it for you. Of course, it's my demo, so it works. But I'm gonna ask Cody to come on stage and talk to you about their own challenges that they had at Stripe.
Hey, so like Rodrigue mentioned, my name's Cody, and I'm the tech lead for observability at Stripe. And that means I oversee our tech and teams that handle our logs, metrics, traces, and profiling data. Today, I'd like to focus a little bit on the metrics case because we went through this big migration last year of getting ourselves onto Amazon Managed Service for Prometheus. But before I dive into that, let's talk a little bit about Stripe, just in case you don't know who we are. When you think Stripe, you probably think payments company. And while that's true, we are a payments company, we like to think of ourselves as a global payments and treasury network with a goal of increasing the GDP of the internet. And we're doing pretty well so far. Last year, we processed $1 trillion in transactions. We did so by handling half a billion, API requests per day, and we did so with 5 nines of reliability. And of course, observability and our metrics play a big role in achieving those 5 nines of observability, or reliability. So I joined Stripe in October of 2022. And I came into what is probably a fairly familiar situation. We had run way over our budget on observability, and we were looking to get costs down. Leadership decided that we were going to take our vendor-based metrics solution and migrate into an open source solution to get our unit costs down and get our observability costs under control. And that open source solution that we decided on was Amazon Managed Service for Prometheus. Also in October 2022, that same month, I drove over to a retired woodworker's estate, and I bought this wood slab. And to be clear, this is in my personal life. Stripe didn't pay me to do this. But this slab is 7 feet long, 3 feet wide, and 3 inches thick. And I'd been talking with my partner about building us a custom dining table. So I was like, all right, it's time. I'm gonna build this. It's gonna take me maybe 1 to 2 months. So let's sell our dining table. Like, let's get the space cleared out because this is coming. Well, 2 years later, this is sitting on my woodshop floor still. My dining room is actually still empty, and my partner loves to roast me about this. So what happened to me here? I fell into this trap where, because I could see the end product, I could envision that, but I couldn't envision all the steps and the time that went into it. I made this mistake of thinking that it was much easier than it was. And this is a pretty easy trap to fall into for a rookie woodworker like me, but it's a pretty easy trap to fall into when you're in software with open source, even if you're not a rookie, right? Like, it's software. We're software people. How hard could it be to run this stuff? But at the end of the day, your vendor is doing a lot for you in exchange for the money you're sending over that way. And this is something that we wanted to keep. So we decided to migrate to Amazon Managed Service for Prometheus, specifically to keep that turnkey behavior, but to get those open source dynamics. And in order to get onto Amazon Managed Service for Prometheus, we had to do it within 1 year because we had to sign a new contract with our vendor. So the first thing we did, like any self-respecting computer scientists, we had a big fight about whether or not we should use a compiler or build AI in order to get us moved over. And what do I mean by moved over? Well, we had 40,000 alerts, 150,000 dashboard queries, and countless components to go with that, including 270 million metrics. So in order to get moved over, we had to perform some automation, because we weren't going to do this by hand, right? A lot of migrations, probably at places you work too, you have the old thing running, you spin up the new thing, you tell people, hey, the old thing's deprecated, please move, and years later, it still hasn't happened. We didn't really have that choice, because there was a lot of money at play here. So what we did was we sat down and we just started hacking out a parser for those alerts and those dashboards. And it would turn out that despite the fact that the input space was really huge, like the language could represent almost anything, the query language, our users were actually only using a very small subset of it. So we found quite quickly that we could parse it. And then we got this handy-dandy intermediate representation. If you've ever built a parser, you know you get an abstract syntax tree, and then you have to compile that into something. And so we started building a compiler. And this is when I realized I was way out of my depth, and my boss, Scott, actually had a compiler expert just on hand who could come over and help me, which was great. I'm sure most Stripes appreciate it, because oftentimes people would come and ask me, hey, can you build this piece? And I was like, that's impossible. And then this other guy would be like, I can have that done in 3 hours. And he would. So Stripe's a lot better for having him. So great. We can move all these assets. The problem is, when you find something wrong with them, what we had was this process where people were just editing it, fixing it, and moving on. But like I mentioned, our input space wasn't actually that large. So eventually, one of us went around experimenting with this intermediate representation, the abstract syntax tree we have in the middle, and realized that if we delete all the nodes that don't really change the semantics, we could find these like neighborhoods of alerts or dashboard queries that were actually all the same. And better, we could leverage that so that when you found a problem with one and fixed it, you could automatically find everything else that needed that fix applied and then apply the fix. And conversely, when you had information about an alert, say you knew one was working, you could go find all the other ones that maybe weren't firing or haven't fired recently, and you could tell the owner, hey, we know this works because we know we translate this one correctly. This went a long way towards getting acceptance here. So at the end of the day, if you have to do your migration on any sort of timeline, my advice is to make sure that you close that feedback loop in an automated fashion as early as possible. Like ideally before you engage with customers, which is not the route that we took, and it was painful. The second challenge, I wrote alert management experience, but I probably should have actually put user experience. The user experience in these open source solutions is often sort of a hidden scale limitation. A great example of this is open source Grafana will pull down an entire, like if it's managing alerts from Prometheus, it'll pull down the entire alert set and then do the filtering client side. And I'm sure this works really well if you have, I don't know, 1,000 alerts, maybe 2,000, maybe even 10,000. We started with 40,000, and we have over 100,000 now. So most of the time, people just get this spinning thing and nothing else at all. And if they're really patient, they might get this. And then inevitably, on our Slack, we get that, which is obviously getting a little old for us. So what we decided to do was sort of take a multi-phased approach to addressing these user experience problems. Initially, during the migration, we actually built a migration-specific UI, and that really helped our users kind of manage their alerts and their dashboards as they transitioned from the old system to the new system. But eventually, the migration finished, and that wasn't a useful UI for us anymore. So in the intermediate term, we built our own alert management tooling into the general dashboard or the general control panel that we have at Stripe. But one of the things I noticed along the way is that if I nag Mark, things end up getting fixed magically. A great example is we logged in one day, and the autocomplete behaves very similarly to the alerts here when you're editing a query. It would try and pull all of the metrics. And when you have 270 million of them, your browser really doesn't like to do that. One day we log in and start editing a query, and I get this slightly different autocomplete thing that tells me that it's using a different filter, and it's really fast. So sorry, Mark, but I'm probably going to keep nagging you a little more. So at the end of the day, be prepared to bridge some of the alert or some of the user experience gap that you have, because it's not going to come perfect out of the box with open source. Generally speaking, they're just not being written at places that have really high scale. And the third challenge we faced, I called it cardinality, but this is a really interesting one for us. So I mentioned we had 270 million metrics on our old solution. When we started piping these to Amazon Managed Service for Prometheus, the number just was going up, even when it was not increasing the old solution. And we couldn't really figure out what was going on. So we reached out to Mark and asked for some help. And his team called a meeting with us. Probably about 2 days later, they messaged us, and they were like, hey, we're seeing some really weird stuff. Would love to have a meeting and kind of figure out what's going on. So they get into this meeting, and they show us this metric. And it has a label on it. And the label's name is error. And the most common value is false. The second most common value is true. And then there are millions of them with a unique stack trace. And the moment I saw that, I was like, oh yeah, we're a Ruby shop. That was probably a Boolean variable. And at some point, it got a stack trace added into it. And we started digging, and we found all kinds of fun stuff. And you've probably seen some of this in your time series databases too, like labels with timestamps in them, IP addresses, URLs, database primary keys, memory addresses, the works. So what it turned out was happening was our vendor solution was just protecting itself on the ingest, right? For the stack trace, it was probably too long, so it was throwing it away. They probably had pattern matching for IP addresses and that sort of stuff. So that stuff, the garbage that we were reporting, was never making it into the vendor solution. But of course, Prometheus, like this open source TSDB, is not going to make any assumptions about what we want to put in it, right? We make an API call to put something in there, it's because we want to store that data. So what we did to solve this was we deployed a stream processor in between our collections on one side and the storage layer on the other side. And the one we use is an open source project called Mantis that was built at Netflix specifically to address these high cardinality or high frequency scenarios where you have large volumes of data and it may be valuable right now, but you don't need to store it, or you might not want to store the entire volume. And on this stream processor, we run jobs to reduce cardinality in data before storing it, or to filter out certain values. And if there is a user who really wants to alert on their database primary keys or their IP addresses or something, IP addresses is actually a valid use case, what we do is we just let them run that right on the stream processor, and it never makes it into the storage layer. And in that way, this is sort of our own brand of disaggregated storage and observability. So the real takeaway here is sort of be ready for the unexpected, or be prepared for the unexpected. And specifically, that doesn't just mean like, be okay with weird things happening, but build yourself some tooling to help you deal with unexpected things. And in this case, like when I like to think about this, it's like if Amazon running the storage layer and the user interface layer is the undifferentiated heavy lifting, this is the interesting part where my team can make a difference in what it is that we're achieving here at Stripe. So how's this all been working out for us? Well, we had an approximately 80% reduction in cost. We've doubled the number of active time series that we're using, and that's no longer all that weird garbage we're putting in there. Like we just have a bigger footprint now, and we are using more metrics. And we've tripled the number of alert rules that we're running on this, which has been great, and we have a lot more headroom still. If you remember earlier in the talk, I mentioned that cost was the impetus for this migration. And so this big reduction is I consider this to be a pretty big win. And with that, I'm going to hand it over to Mark, who's going to tell you what's new in open source observability.
Thank you, Cody. Thank you for sharing some of your observability journey with us, mainly around the challenges, the solutions, and obviously the lessons learned in adopting some of our managed services. I'm hoping that some of the new features I'll be announcing and sharing with you today will help free up some of your time so that you can focus on finishing what matters most to you, maybe your table, so that your next project is not probably, if I figure out how to do this, a doghouse for you and your family. My name is Mark Shaney. I'm a senior manager at AWS, and I'm here to talk to you about some of the new features for Prometheus, Grafana, and OpenSearch. In the last 5 years, through a lot of customer conversation, these 5 themes continue to come up. And these are some of the things that we've done to help address some of the needs that our customers had. Starting first with scalability. So scalability is around the undifferentiated heavy lifting of being able to scale to meet the highest demand for that our customers need, but also the ability to provide a highly available and reliable service. Since day one at AWS, things that have impressed me the most is our customer obsession, of course, but also the scale at which we operate. Scaling at AWS is a continuous journey. But for some of these open source projects, these are not things we can do by ourselves. These are things that require us to collaborate with the open source community to be able to deliver the scale that we need. Last year, we announced support for 500 million active time series metrics per workspace and 30,000 rules. A workspace is the isolation and security of the space where you ingest, query, and store these metrics. I'm happy to announce that we now support 1 billion active time series per workspace and 100,000 rules. So this gives you the ability to unify all of your metrics across your EKS clusters, your EC2 environments, across all your accounts, your hybrid environments, as well as multi-cloud environments. Similarly, in Grafana, we used to support 500 concurrent users, and now we support 1,000 concurrent users, helping you unify all of that data, that observability data that you need for your largest teams in your environments. Next up, cost effectiveness. Is there anybody here not being asked to be able to reduce their cost or monitor their cost? Anyone? I know Stripe did. you can spend as much as you want, that's what you're saying? Cost effectiveness is something that's also impacted us as a service owner. I am responsible for managing my costs for my services. And it's something important to be able to consider. So one of the things I want to cover is how can you consider things that you may want to consider as part of unifying some of this data to help get more value out of your observability data, but also saving some of your costs. So I'll talk about 3 different logs, sources that may be useful for some of the university, completing that observability picture and consolidating and correlating a lot of that information, such as VPC flow logs, CloudTrail events, and AWS web application firewall logs. But before I go there, one of the cost-effective ways to do this is through vended logs. Vended logs is a log that's emitted from AWS services, 2 different delivery destinations like CloudWatch, Kinesis Data Firehouse, or S3. And the one thing that you want to be able to do is think about how you want to analyze those logs. If you can centralize that, you can take advantage of tiered pricing for some of these vended logs, which means your cost can go from 50 cents to 5 cents as you reach these higher tiers. That's a 10x reduction right there. So let's dive a little bit deeper in some of these logs that you have. So VPC flow logs is a good source of information for you to understand how your workloads are interacting with any AWS resources in your VPC network. Great opportunity to understand your top talkers, understand network latency, and any bandwidth that's being used within your VPC, helping you with network troubleshooting, security monitoring, as well as capacity planning. You can use this here to be able to learn more about how you can do this in your own environment using Grafana and VPC flow logs. CloudTrail event is also a great important source of information to be able to not only meet your compliance and auditing needs, but it also helps you understand what changed in your environment. So who changed what, where, and why. And ultimately, this can help you understand changes impacting your performance. Compliance is also a very important thing. You want to be able to understand requirements in terms of, are you meeting your SOC compliance, HIPAA compliance, FedRAMP compliance, and this is all the great source of information that you can get from the CloudTrail events. I've also shared a link here to be able to learn more about the types of events, the schema of the events, and how you can query these events in your environment. The third source of information that I want to talk about is the web application firewall logs. So the WAF logs is an important part of also understanding the traffic that comes into your network, and ultimately be able to block unwanted traffic like bot traffic that uses more infrastructure to process these transactions, which also costs you more money. Also helps you better understand security events and potential threats, understanding things like the IPs that are connecting into your applications and your resources, as well as your user agents. I've shared 2 links here that you can actually learn how to do that. I've also shared an open search blog where you can use actual anomaly detection using the random cut forest to be able to understand seasonal data, to understand these different web application patterns so that you can put in the right rules to effectively cut down on some of this traffic that will save you back on these resources being used. By a show of hand, who uses OpenSearch to do security or observability data? Anyone? A few of you? Great. So OpenSearch is a very powerful analytics engine to be able to not only analyze your observability data, but your security data. It uses a query language called pipe processing language, which uses a set of command that sequentially executes to be able to provide this powerful search language capability to be able to extract anything that you want from your data. It can be challenging to have to bring all that and unify all that data together like the sources of information that I just talked about in terms of the logs that I talked about. Effectively, you need to understand how to manage these complex pipeline, be able to bring that data together, which actually ends up being more additional cost to you. You also have to learn different languages if you don't do that, right? I got to learn SQL to query CloudTrail. I got to use CloudWatch Logs Insights query language to be able to query your logs in CloudWatch. I got to use SQL or PPL to query your logs in OpenSearch. It's not an easy task for your engineers to have to learn 2, 3, 4 different query languages. And then ultimately, you got to use different visualization tools. Your AWS console, Grafana, OpenSearch dashboards, right? Swivel chair approach where you can't correlate all this information together. So I'm excited to announce that we've unified the analytics capability and simplified the way that you can actually query a diverse set of data sources. eliminating the need for extracting, transforming all of these logs into OpenSearch, effectively reducing some of your costs so you don't have to copy the data in different locations in case you do have different teams that use the data in different ways and want to use these different query languages. And also, having to learn these different languages, again, is costly for engineers. And ultimately, be able to unify this all in one area. So directly from the Amazon Search Service, you can click on the left menu and be able to add new data sources. In this data source, you can actually choose CloudWatch. So assuming you want to streamline all your vendor logs into CloudWatch, or you already have logs in CloudWatch, you can see all your logs there without having to move them, try to move those logs. From there, you got a couple setups in terms of permissions you need to access, and then click Done, and then you can automatically start driving all directly in OpenSearch. On top of that, we provide out-of-the-box dashboards for some of the logs that I mentioned above in terms of VPC flow logs, CloudTrail events, and WAF logs. So you can get immediate value in driving value in terms of understanding what's driving some of these bottlenecks or issues in your environments. Next up is portability. During a recent customer conversation, an engineer came up to me and says, I love open source. But the open source observability tools is like a bunch of Lego blocks. It needs a lot of manual effort for me to get the value I need from these tools. I think we had Cody share some of these examples of what's going on with some of these open source tools. And it can be true. It goes everything from understanding what you need to collect, how to collect it, what you need to monitor, what alarms you need to set up, what are the right signals that I need for monitoring these continuous changing workloads in different compute environments. And then how do I deploy this using and integrated with my CI/CD pipeline? And then ultimately, how do I make this consistent across all my AWS accounts, all of my different compute environments? I'm excited to announce that we've just announced our support for an observability solutions catalog, so 30+ pre-built solutions that allow you to give you opinionated telemetry signals for collecting data, providing default dashboard and alarms for some of these third-party solution and AWS services. This is a foundational set of observability solutions that you can easily get started, learn from how we monitor these applications, and customize as you need across both EKS and EC2. The solutions are provisioned as infrastructure as code, so you can easily integrate it as part of your CI/CD process. We use CDK or Terraform to be able to do this today. And you can start directly from the in-console experience. And then ultimately, it provides that consistent experience that you're looking for to monitor some of these applications. So let me show you how to get started. Directly from the CloudWatch console, on the left side, you have the telemetry configuration. From the telemetry configuration, you can click on Explore Observability Solution to bring up a list of 30+ different observability solutions that you can deploy directly within the console. So let's start with Amazon Elastic Kubernetes Services. So EKS. So in EKS, I want to be able to deploy this to my managed open source services, Prometheus and Grafana. By clicking on this, I will get a step-by-step instructions on how you can use CDK or Terraform to be able to deploy the application to existing EKS clusters and leverage my existing Prometheus workspace and Grafana workspace to be able to go visualize the information that's automatically collected. This will also deploy our AMP collector that Rodrigo was talking about, which is our serverless collection capability to be able to discover and automatically scale the amount of collectors we need to be able to collect those metrics. So this will end up showing 11 or so different dashboards to monitor the performance and health, including the logs that you have inside your EKS cluster. You can go ahead and click on the dashboards and be able to get automatic visibility into your performance, your CPU, memory, all of that performance from your infrastructure cluster without having to repeat the same thing that you could learn from open source or figure it out yourself. We'll provide that visibility and that opinionated observability solution for you. So no session would be complete without talking a little bit about AIOps or GenAI. So some of the things that we talked a little bit about anomaly detection. I showed you a blog. You can go through it and learn more about how to use anomaly detection. It's a feature that's supported in OpenSearch. But we also announced support for AI assistance to OpenSearch and AI-powered natural language query. Deploying your AI-powered search applications in OpenSearch offers predefined templates to automate the setup and the models that you need and integrates with connector to APIs such as Amazon Bedrock and OpenAI to allow you to build your own applications, such as semantic search. Some of these examples of this are open search assistants that can help you recommend the right visualizations based on the type of data that you're analyzing. Natural language queries can also help you, engineers that are not specialists in either SQL or PPL, to get started much faster. You can simply ask in plain English, what are the top errors that I see, and ultimately it will generate the PPL, run the query, and be able to see the data that you're looking for. So hopefully that'll help your teams get started quicker, get immediate value using some of these AI capabilities available in OpenSearch. And look for more, there's gonna be some more this week that's gonna be announced. So 5 years ago when I started this journey, the reason why I wanted to do some of these open source projects is, one is I wanted to learn from the open source community, but I also wanted to contribute back to the open source communities through this collaboration that we have. In 2021, AWS and the open source community created OpenSearch. This project has exceeded 100 million or 700 million downloads. It's a very thriving community, as you can see there. We've contributed to over 23 different releases. In September, AWS transferred OpenSearch to the Linux Foundation, a non-for-profit organization which is a trusted home for some of these open source projects. We've also partnered, the OpenSearch Foundation has also partnered with several other enterprises out there, including AWS, SAP, Uber, Atlassian, and many more. So I encourage you to go look at OpenSearch if you're trying to self-manage, or look at a fully managed service if you're interested to learn more. The same is true for some other projects that my team have strongly contributed to in terms of Prometheus, for projects such as Cortex, Prometheus, Thanos, and OpenTelemetry. If you're interested in doing more for the open source community or want to learn how to use these tools, please come and see me after this session. Would love to talk to you about what you can do there. So to recap, we talked about 3 managed services: Amazon Managed Service for Prometheus for your high cardinality metrics, Amazon Managed Grafana for your rich data visualization, and Amazon OpenSearch Service for the powerful analytics across your logs and your traces. And we talked about benefits, compliance and security. We'll take care of making sure that our applications are compliant when it comes to SOC compliance, FedRAMP compliant, all these types of compliancy, and making sure that you have security around integrations with identity access management to be able to secure your application and make sure that you have the right authentication and authorization for people that need to access it, for your engineers. Operational overhead, we'll take care of the undifferentiated heavy lifting of scaling and making sure that we can meet your demand now in terms of the number of active time series metrics or the volume of gigabytes of logs that you're ingesting, and make sure that we can meet your needs in the future as well. From a rapid release cycle, we'll continue to make it easier for you to provision these resources directly using CloudFormation, CDK, and make sure you get more values out of these solutions much quicker with things like observability solutions that we just launched and zero ETL, so you don't have to move the data around. And then most importantly, 24/7 support. You don't have to carry a pager anymore to figure out how to support these solutions when something goes wrong. We're there to proactively also notify you through personal health dashboards or service health dashboards if there's degradation of the service, so you understand what's going on with the service. And hopefully help you gain a little bit more time to do your personal work, like maybe finish your table. All right, if you're just getting started with some of our open source services, check out our workshop or documentation, labs, skill builders as well. There's a bunch of good information there to get started, or if you're just trying to learn more information. And then obviously come see us at the CloudOps booths. We're there to answer any questions. There's gonna be some subject matter experts, and of course there's swag if you're looking for swag. And don't forget to fill out the mobile survey. I know Rodrigo's looking for all 5s, so please help him out here. And I'd love to also take any questions. We're gonna come down back on the floor here, so if you have any questions for us, please come and see us. Thank you so much for joining.